Welcome to section 5.2, part 2, regarding polynomials, linear factors, and zeros. We're going to start this chapter, or this section of notes, with a little review problem. This is not in your note packet. I just want you to pay attention as I'm working through this problem, and hopefully you're working through it with me. We want to write a polynomial in standard form when x equals 2 and negative 5. So these, 2 and negative 5, are our zeros. Well, how do we go from knowing the zeros to writing the zeros as a factor? Okay, remember the factor theorem. It says if a is a 0, then x minus a is a factor. So I can just rewrite this as x minus 2. Or over here, for the 5, I can write it as x plus 5. Basically what you're doing is moving each constant over to the other side, so it's set equal to 0. We're going to multiply these two together. So we get x squared plus 5x, and then we have minus 2x, and then minus 10. So x squared plus 3x minus 10. Okay, now we're going to start moving on to the new stuff here. We want to define relative maximum and relative minimum. And the reason that they're called relatives, we already know what a maximum is and what a minimum is. But there are graphs that have more than one maximum, such as this one. So we know that given this random shape, we have the end behavior is both up, up. So we're looking at an even degree. Well, and we have 1, 2, 3, 4, 5 possible turning points. So a possible degree could be degree 6. Okay, in this case, we have a maximum here, we have a maximum here. If I wanted to know relative maximums, you'd give me all the maximum values. And that's what relative maximum would mean. So the formal definition is the value of the function when the graph switches from increasing to decreasing. Or maybe you want to rewrite this as the value of the function at the up-down point. Because our graph would be increasing and then it's going to go back down. And relative minimums work the same way. In this example that I drew, we have 1, 2, 3 possible minimum values. If the problem said write the relative minimums, you would have to give all 3 minimum values. So we're going to write this definition as the value of the function where it switches from decreasing to increasing, or at the down-up point. And just to make sure that you know when I'm saying down, I'm really talking about decreasing, and up refers to the increasing switch. Example 5. We want to find the relative maximums and minimums in our calculator. And our function is y equals 3x cubed plus x squared minus 5x. So I want you to take a few minutes right now, hit pause, and let's see if you can calculate the maximums and minimums. I'm going to show you what my answer is, and I want to see if you match. Now, if you do not get these answers, make sure that you come up to me at school and we can go over what's going on with your calculator. Okay, from our graph we see that we have, well actually let's go back to the function. From the function we know it's a cubic, so we should have at most 2 turning points. Now when you go to graph it, you'll notice that you have a maximum turning point there and a minimum right there. So we're going to go ahead and calculate those maximums and minimums, and again hit pause, see if you match. So I went through the feature in my calculator and I got the maximum to be approximately negative 86 hundredths when y is at 3 and 13 hundredths. All right, now let's go through and try to do the minimum value. So for my minimum value, I got x to be approximately 64 hundredths and y is about at negative 2. Hopefully your answers match. Let me know. This concludes our notes for today. If you have any questions, make sure you come in to ask me.